Okay, so let us do one more question and then we will start the next topic. Okay, so this is one of very important questions and also important because your pattern for CBSE examination, board's examination will be similar to the earlier board examinations, right? You have some chapters which are deleted, but the pattern will be same, not like the previous year. You will be having everything which is subjective and MCQ nahi hoga. So this question you can see that has been asked multiple times in CBSE also and in other boards also, right? 9, 2010 and so it is also there in NCR. So please write this question. It has two parts. We'll do one by one, each of them. Vapor pressure of chloroform and dichloromethane at 298 Kelvin or 200 mmHg and 415 mmHg. So what I am doing, I'm just writing the Rawls law here. So P total is equal to pressure, partial pressure by A and partial pressure due to B. And we can also write PA as P naught A chi A plus P naught B chi B. Okay. Let me know when you're done writing the question.
Done, sir.
Done with it? Okay, fine. So calculate the vapor pressure of the. अच्छा ठीक है. यहाँ पे ना एक काम कीजिए of each component. The last part here ना. I think this is a mistake here. Can you please cut this? In solution मत कीजिए. यहाँ पे सो काट के लिख दीजिए in vapor phase. Okay, in vapor phase. Now the question will be interesting. You don't have to find the mole fraction of each component in the solution. Rather, in the vapor phase, you have to calculate the mole fraction because we all know that just above the solution that we have here, there will be vapors, and obviously there will be two types of particles in the vapor. One will be of chloroform and the other will be of dichloromethane. And you have to find the mole fraction for each of them that is present in the vapor phase. That is present here in the vapor phase. Okay. That is the second question. The first question is calculate the vapor pressure of the solution prepared by mixing. Now this is how we have to start the questions always. What has been given? 25.5 gram of CaCl3, 40 grams of CH2Cl at 298 Kelvin. Okay, so write this down. 25.5 gram of CH-Cl3 and 40 grams of CH2 Cl2, and they have asked calculate the vapor pressure of the solution. Then the vapor pressure of the solution, that means they are asking the vapor pressure that is due to the solution, and for that we need the Rawls law. So Rawls law is here. P total is equal to P naught A chi A plus P naught B chi B. So P naught A is what? What is P naught A? Tell me. What do you mean by P naught A? What does it denote? What is P naught A?
Vapor pressure of pure component.
Vapor pressure of pure A, vapor pressure of pure B, right? So if I see here, we can take that chloroform, let us say chloroform is A here and dichloromethane is B, then we can say that P naught A is what? It is the vapor pressure of pure chloroform. So it has been given 200 mmHg and 514 mmHg. So this has been given. P naught A and P naught B has been given. You have to calculate the chi A and chi B. So that is also easy. That means you have here 25.5 gram of CaCl3. So from this, you can calculate the number of moles of CaCl3, right? And from here, you can calculate the number of moles of CH2Cl2, number of moles of CH2Cl2. And this is what this is? The given mass divided by the molar mass, and this will be also given mass divided by molar mass. So what is the given mass here? The given mass is 25.5. Okay, what will be the molar mass for CHCl3? Chlorine is how much? 35.5, right? 35.5. So ये 5, 5, 5, 15, 15, 15, 15, 15, 16.5, 16.5, 16.5, and 90, 16.5, 16.5, and 90. So 105, and then you have, so CHCl3 it will be 119.5. CHCl3 will be, please confirm this now, 119.5.
Yes, exactly.
119.5, right? Grams per mole. 20 grams. Now CH2Cl2 will be equal to how much? It is 40 grams. 35, 35, 70, 70 और 71, 71 और इधर 4 और कार्बन 12, 12 और 14, 14. So this will be equal to how much? CHCl2? 71, na? 35 plus 35, 35.5 plus 35.5, 71. And then you have from carbon 12 and 2 here. So this will be equal to 85, right? Correct?
Yes, sir.
Yes.
And 85 grams per mole. So you need to calculate the values for this. Please calculate this value for both of them. Grams and grams will cancel out each other. You will get the answer in moles. Send the answer in chat, okay? Number of moles of CHCl3 is 0.21. ठीक है. Number of moles of 0.CH be 0.47, guys. I think so. It will be 0.47. Nearly like it should be near to 0.50. Very near, है ना? तो 0.42 नहीं होगा, 0.47 दो लोगों ने दिया. I think that is the right answer. Okay, so this will be equal to 0.47 moles. Right. Now you can easily calculate the chi A and chi B. So mole fraction of CHCl3, it will be equal to 0.21 upon 0.21 plus 0.47. Okay, calculate this and tell me what is the answer. Samaira, आप देख लीजिएगा एक बार. This is 0.47. ठीक है. What will be the mole fraction now? The mole fraction is coming out to be 0.308. Okay. So the mole fraction of CHCl2 will be equal to how much? 1 minus 0.308. Right. So what will be the answer here?
Sir, is it okay if we just take 0.3?
Is it okay if we just 0.3? You can, but I mean, it will depend on the teacher. Now you're on the लाइक वो डिपेंड करेगा जो सीबीएसई में चेक कर रहा है एग्जामिनर, है ना, कि वो आपको दे सकता है कि नहीं मार्क्स दे सकता है इसमें। बट जनरली आई वुड से दैट एटलीस्ट आप इतना तो कर दें, बिकॉज दीज आर इजी कैलकुलेशंस, है ना, नॉट वेरी टफ। ओके, सो
So
इट
it'll
इज
be
कमिंग अप,
0.692.
हाँ 0.692, 0.692. Okay, now it is fairly easy question, है ना. The first part is very easy, that p total, it is just calculation. It's like rarely any chemistry here. You are having p naught chi of, let us say, ch, p naught and chi both for, इसको ऐसे bracket में कर देता है ना, CHCl3, and chi is also for CHCl3 plus p naught of CH2Cl2 and chi of CH2Cl2, right? So the p naught is equal to how much for CHCl3? It is equal to 200 mm of Hg. It's just 200. And chi is how much for CHCl3? It is 0.308. So since mole fraction, it does not have any unit, so we'll just write for this, the pressure is 415. Yeah, 415. 415 into CH2Cl2 is 0.692, and whatever the unit is coming out to be, it will be in mm of Hg. Okay, so you just need to calculate these two values. So ये कितना हो जाएगा आपका, 30, 30, 60, 60 और इधर 8, 8, 16, 60 और 16, so it's 61.6 plus, okay, it is coming out to be 348, I think. Let me calculate again. Just 348, 348.78 mm of Hg. सैयद मोहम्मद, एक बार आप देख लीजिए. हाँ, Samira, you are correct about the earlier statement. सैयद मोहम्मद, नहीं, आपका ये गलत है थोड़ा, इस वजह से शायद कुछ डिफरेंट आंसर आ रहा होगा. सैयद मोहम्मद, योर मोल फ्रैक्शन फॉर CH2Cl2, that is not at 0.698 नहीं होगा, it will be 0.692. बट स्टिल एक बार आंसर देख लीजिएगा आप लोग, ठीक है. सो प्लीज राइट दिस डाउन. Raise your hand when you're done, okay? Okay, most of you are done. Waiting for Hania, Khalid, and Said Mohammed.
Done, sir.
Done. Okay. Said Mohammed, can you please speak? I could not understand what you have written. Said Mohammed, can you please speak? Okay. So now let us move on to the next question that they have given us here. That mole fraction of each component in the vapor phase. Okay. So next question is what? Mole fraction of vapor phase of each component in vapor phase. That means what are they asking? They are asking that if we have any liquid like this, let us say there are two liquids and there will be two kinds of vapors also, right? There will be two types of vapors, and they're asking what is the mole fraction of the blue one and what is the mole fraction of the yellow one. Okay, so generally what we show when we write mole fraction, we write in the terms of chi only, but since here we have mole fraction in the vapor phase also, and there will be mole fraction in the solution phase also. Please listen very carefully. The solution also, we are talking about the chi of A and chi of B. So just in order to differentiate them, in the vapor phase, we write that y of A and y of B. Okay, just to differentiate between the aqueous phase and the vapor phase. So if you have in solution, okay, we write mole fraction as chi, and in vapor phase, we write this as y, just to differentiate, है ना? ऐसा नहीं कि हर वेपर फेज में ही आप y लिखने लगिएगा, अगर दोनों ही मौजूद है ना, when you have solution and its vapor phase, है ना? So for solution you will use the chi term, and for vapor phase you will use the y term, है ना? You will use the y term. So you have to calculate. So now tell me, how are you going to calculate this? देखिए, how can we calculate what is the total pressure? ये तो अब gas है ना? Now we will treat this as gas, ठीक है? What we have been given that this is our gas. यहाँ पे you have blue gas atoms, right? You also have yellow gas atoms. अब ये बताइए, what is the total pressure? What is the total pressure here? What is the total pressure? What happened, guys? What is the total pressure? ये तो गलत बात है ना, आप लोग ध्यान नहीं दे रहे बिल्कुल. We have just calculated what? What is this? What is this value that we have calculated, guys? कहाँ है? Please focus, huh? What is this value here that we have calculated?
Vapor pressure.
Vapor pressure, and that is only the total pressure, na? Vapor pressure, vapor कहाँ पे है आपका? These are the vapors only, right? Yes or no?
Yes, sir.
है ना? So that is the total pressure. Is it clear with everyone? Yes or no? Please tell me. Hania, Ishma, Khalid, Matthew, Mazia, Minashi, Nawal. You guys don't answer. What is this behavior? ऐसे चलेगा तो फिर it's fine, है ना? तो फिर आप लोग लिखिए जवाब. I can tell you the answers right directly only, na? So you will write like this using Dalton's law of partial pressure. Using Dalton's law for partial pressure, you can write that Y. That means Y of CHCl3. This will be equal to how much? This will be equal to whatever you have calculated. Whatever you have calculated here. That means the total pressure. That means the total pressure. Simple सी बात ये है कि according to Dalton's law of partial pressure, the pressure due to CHCl3, it is equal to how much? It is equal to the mole fraction of CHCl3 into the P total. यहाँ से आपको क्या मिल जाएगा? यहाँ से आपको मिल जाएगा Y of CHCl3 will be equal to how much? Will be equal to the pressure due to CHCl3 divided by the P total. ठीक है? Similarly, what you have to calculate? Similarly, you have to calculate Y of CH2Cl2 is equal to pressure of CH2Cl2 divided by P total. ठीक है? Now, if you ask me, then I will explain this. ठीक है? If you ask me how is this coming, sir? How is this coming, or how is this value coming? Then I will explain. Otherwise, you can write and you can solve it. चलिए. If you have doubt, then you will ask. So all of you know, right? What is the pressure of CHCl3 that we have calculated here? सारी values हैं यहाँ पे. See, this is the pressure of CHCl3 that we have calculated, ना? 61.6 and 287.8. This is the pressure or the partial pressure due to B CH2Cl2. चलिए, please calculate. अभी आ रहे हैं कुछ लोग तो. Very nice. Calculated. CL3 is how much? 61 point. What we have calculated? 6 upon total pressure was 348 point. Pressure of CH2Cl2 is equal to 287.18 divided by P total. P total is equal to how much? 348.78. Please calculate these two values. Okay, Khalid. Yeah, this will be 0.17. है ना? So this you can calculate it also, or you can just write that whatever the mole fraction for CH2Cl2, it will be equal to. So you can write 1 minus 0.17. है ना? So either you calculate this value or this value, the answer will be same. हाँ, fine. Salman, your answer for if you will add both of these terms, they should be equal to 1, है ना? So you have done some mistake, I would say. For the second case, first वाला तो आपका सही है. Yes, Samira, correct. This will be approximately equal to 0.83. 0.83 हानिया, not एक decimal place से मत छोड़ा कीजिए कभी भी. Always have at least two non-zero digits after decimal point. Okay, at least two non-zero digits after the decimal point.
So it's coming 0.823.
हाँ वो आएगा अगर आप इसको सॉल्व कीजिएगा तो ना.
Yeah.
हाँ वो इस वजह से आ रहा है क्योंकि अगर आप इसको सॉल्व कीजिएगा तो दिस विल बी अराउंड इक्वल टू 0.179. ठीक है, तो हम
Oh.
बट अगेन द एरर इज नॉट मच. 5% का जो एरर होता है ना, 5%, if you have an error of 5%, now error is again which one? Error that you studied in physics first class, unit dimension measurement, है ना? In measurements there was error. So if you have error of 5% in your answer, ठीक है, then it is fine. You can carry on, marks नहीं कटते उसमें generally. Now that is the rule actually, है ना? And how much it is followed, you can't say that. So always be in safe side. Two non-zero digit after decimal point. If you use this formula, if you use this rule, then it will be always fine. Acha, first of all, tell me, all of you understood this part? Yes or no? Tell me.
Yes,
ये कितने को समझ में आया?
Yes, sir.
You remember it from Dalton's law of partial pressure? या फिर you can prove it now. Can you derive this equation? या फिर बस आ गया, मतलब सर आपने लिख दिया तो होगा ही. Now tell me how many of you understood this question. ये देख लिया, पढ़ लिया, याद रहेगा वो नहीं पूछ रहे हैं. How many of you understood this equation? Why the mole fraction of something is equal to its partial pressure divided by total pressure? No one. Huh? Samaira,
Not
Salman. What about others? Now this is a good time, no? This is a good time to revisit states of matter. दिख रहा है आपको? Same thing ना? Yes or no? Tell me. Pressure of second gas, pressure of third gas, right? It is equal to mole fraction into P total. So mole fraction क्या हो जाता है आपका यहाँ पे? It will be equal to partial pressure divided by P total. Is it there? Yes or no? As it is in
Yes.
11th standard.
Yes.
ठीक है. Now here also don't worry. Okay. बस इसी चीज को नाम क्या करते हैं, थोड़ा सा खोल के लिख देते हैं all of you. Okay. So I will write this as y1. It is equal to P1 upon P total. Okay. Now this is for gas, right? Yes or no? Please tell me. Pressure will be for gas. Yes or no? Right. So I can write this as N1 R T upon V1. Yes or no?
Yes, sir.
Correct है? Okay. We can also write P total will be equal to what? P total will be equal to number of moles, that is total, R upon RT upon V2, है ना? But V2 और V1 लिखने का मतलब नहीं बनता because all of these are in same container, है ना? एक ही container के अंदर है, so it is just V here. Now you can see that what are the things that we can cancel? We can cancel RTV, we can cancel RTV, and this will be equal to what? This will be equal to N1 upon N total. अब N1 upon N total ही क्या होता है आपका? मोल फ्रैक्शन होता है. Yes or no? Got this?
Yes, sir.
Okay, so this is how the derivation has come, that mole fraction of any component, any gaseous component, is equal to the partial pressure of that gas divided by the total pressure. Okay, partial pressure of that gas divided by total pressure, and that is why this question is important, because it has a component from 11th standard. This is a component from 11th standard. अगर इसकी बात करें यहाँ पे हम, if I see here this part, so this is not the chapter solution, right? This is the chapter that is gaseous state. And that is why this question becomes important, because you have been asked about gaseous state in the context of solution. जो start हुआ है सवाल वो किसने start हुआ? That is in solution. But at the end you are getting a question from gaseous state, purely gaseous state. There is nothing that has been used here. Whatever we are using the formula, it is one formula only, and that is of gaseous state. Okay, so that is why this question is very important. I will suggest that please redo this question, and you have to redo this question until and unless you are able to redo it without looking. And there should be at least half an hour gap between each attempt. So you read once, okay, you read once, then half an hour, after half an hour, you attempt the whole question. And if you are getting the right answer, then it is fine. And if you can't, then again read the question, then wait for half an hour, or you can study different things for half an hour, then again attempt this question and check if you can do it, yes or no. Okay, because this has been repeated many times. Okay. Now this is done. Let's write a topic. Rod's law as a special case for Henry's law. RAOULTS. Rod's law as a special case of Henry's law. Now see, if you remember Rod's law, this is not the equation for Rod's law, right? P total is equal to P naught A chi A plus P naught B chi B. Now please remember, this is not the equation for Rod's law. Okay, this is not. What is the equation for Rod's law? Rod's law says that the partial pressure of any gas is directly proportional to its mole fraction. And partial pressure of any liquid is directly proportional to its mole fraction, and partial pressure of any gas is equal to the vapor pressure of pure liquid into its mole fraction. This is your Rod's law. Please remember that this is your Rod's law. Okay, and this is an application of Rod's law from which we can calculate the P total. That's it. So if you compare Rod's law and Henry's law, so I will write here Rod's law and Henry's law. What is Rod's law? The pressure of, or the partial pressure of any gas is equal to that vapor pressure of the pure liquid into the mole fraction. Similarly, what is Henry's law? Henry's law says that, what does it say? It says that the pressure of anything, it will be equal to KH into chi B. That means, what is chi B? Chi B, we can say it is the solute here, and you can also write chi A. It doesn't matter, whatever the gas is there, chi B or chi A. Now, can you see the similarity here? Here also we have mole fraction. Here also we have mole fraction, right? Here, this is also a constant, right? And this is also a constant. Yes or no? Can all of you see this? Yes or no?
Yes, sir.
Now, in this case, what we can write? In this case, we can write Rod's law becomes a special case of Henry's law. Becomes a special case of Henry's law in which KH becomes equal to the vapor pressure of pure component. Vapor pressure of pure component. And even if you look at, now this is a bit technical, but please try to understand this. Okay, please try to understand this, that if you look, we said now, what is KH? If KH is high, then the solubility is low. Yes or no? Please tell me. Do you remember this point about KH, Henry's law constant?
Yes,
If
sir.
KH is high and solubility is low. Similarly, यहाँ पे भी आप देखिए, if the vapor pressure will be high, if the vapor pressure of a certain liquid is high, that means it will not be staying inside the solution. It will be evaporating easily. If it is evaporating easily, then also what? The solubility is low only, no? If it is not staying in the solution, then what? You can say it is solubility is low, yes or no?
Yes.
Okay, so this is why we say that Rod's law is a special case for Henry's law. And in that special case, what happens? The KH, the value of KH, it just changes from KH to the vapor pressure of pure component, pure component. But still, if you see in essence, these are the same things only. P naught A also, if it increases, the solubility decreases, and KH also increases, then also solubility decreases. Okay, so please write this point and let me know when you are done.
Done, sir.
Now, the next topic is very important, and it is conceptually important. You will not get many numericals from here, but conceptually it is important. Is right, ideal and non-ideal solution. Right, the topic ideal and non-ideal solution. Okay. Ideal and non-ideal solution. So first of all, we will deal with ideal solutions. Ideal solution. Okay, so what is ideal solution? We will write the definition of an ideal solution first, and we will then understand what is the relationship between the ideal solution and whatever the criteria has been given to us. At first sight, it will not look very clear. Please write an ideal solution. An ideal solution is defined as the solution which obeys Rawls law exactly. Rawls law exactly over the entire range of temperature. Sorry for this. मेरे मुंह से निकल गया. Entire range of concentration, not temperature, concentration. Can you write this, and I understand that initially what is the relationship between the ideal solution and also में क्या relationship है वो समझते हैं, ठीक है? Write this down. It is saying the partial pressure of A, this is also partial pressure of A directly proportional to chi A, and we can write partial pressure of A is equal to P naught A chi A. Okay. Similarly, we can also write P naught B, sorry, PB is equal to P naught B into chi B, and P total hoga, that will be equal to P naught A chi A plus P naught B chi B. यहां तक लिखना है बस आपको, ठीक है? वेट अ सेकंड, बस यहां तक लिखना है आपको. Don't have to write anything else, just write till here. उसके बाद पेन वगैरह छोड़ दीजिएगा बिल्कुल. You will understand this. Zarsh, how are you?
Fine, sir.
Fine. But it seems you are late. You are not fine. What happened? टाइम नहीं मिला था क्या सही आपको मैसेज में?
नहीं, वो एक्चुअली आज स्कूल गई थी तो लेट हो गया था.
Oh, where is your school by the way?
दमाम.
अच्छा, Dammam. So is it like far away from your place?
Yes, sir.
Okay, so when do you come back?
Now I have taken TC from school.
Oh, TC ले लिया आपने? क्यों? फिर क्या कीजिएगा?
वो अलीगढ़ मुस्लिम यूनिवर्सिटी में एडमिशन हो गया था तो.
अरे वाह माशाल्लाह. But which standard?
I think जुलाई और जून.
नहीं, अलीगढ़ मुस्लिम यूनिवर्सिटी में अभी आपका वो ये हुआ है,
ऑनलाइन
रिजल्ट आया है. सॉरी, नहीं, अभी रिजल्ट आया है इसका एंट्रेंस का.
लेकिन अभी मैंने टीसी लिया है.
अच्छा, रिजल्ट पहले आ चुका था, अभी आपने टीसी लिया. ऑनलाइन क्लासेस चल रही थी आपकी. 11th आपने यानी एमयू से किया है?
नहीं, मतलब हम इंटरनेशनल इंडियन स्कूल से करे थे, लेकिन बस एमयू का अभी फिलहाल आया था, इस मंथ आया था.
तो वो तो फिर लेकिन 11th में लेंगे आपको नहीं?
वो सिर्फ फाइनल एग्जाम होगा एक, उसके बाद फिर वो प्रमोट कर देंगे 12th में.
एक फाइनल एग्जाम होगा लेकिन क्लासेस नहीं होंगी?
जी नहीं.
अच्छा, और आप यानी कि आप 12th का जो बोर्ड दीजिएगा दैट विल बी इन 2023 ओनली, है ना?
Yes,
अच्छा अच्छा, गुड गुड गुड. सो फिर नाउ यू आर गोइंग बैक. अब मतलब गोइंग बैक का क्या आप शिफ्ट कर रही हैं फिर अलीगढ़?
जी सर.
व्हेन?
End of this month maybe.
At the end of this month. अच्छा, I will be there like in AMU next month around 24 25. I also have to take my sister to for the entrance examination. She's in 9th standard now, so I have to take her. Good. Congratulations. Okay, everyone done now? Yes or no? हाँ जी बताइए. Everyone done?
Yes.
Yes,
Okay,
sir.
fine. Now let us understand. We have got two liquids here. Okay, we have got two liquids, and there will be two different kinds of vapor particles here, and there will be two different kinds of gas particles here. Simple सा case लेते हैं. We will say that the blue one, let us say that is chi A, which is equal to 0.7. ठीक है? This solution, I have only made this solution, and we have seen that we have taken 0.7. The mole fraction for water is 0.7, and whatever this yellow one is, that is chi B, this is equal to 0.3. Okay, we have taken its mole fraction as 0.3. We have taken its mole fraction as 0.3. Concentration, we know it. Now what we can do, we can also add a manometer or barometer here, and this will tell me the total pressure. And because यहाँ तो total pressure आएगा, partial pressure तो आएगा नहीं. Here you will be getting the total pressure, right? So we can measure this thing. P total we can measure it. Mole fraction of A and mole fraction of B. These are the two things that we have decided, and then we have prepared the solution. Right. So we know this thing, P total. Now this is what we have measured. So we will say that this is experimental. Right. This is experimental. Okay, this is experimental. And then we have got these values for chi A and chi B. And chi A and chi B we have got. And also, all of you can agree that if I want to Google what is the vapor pressure of pure liquid A and pure liquid B, that also we can get from the internet, from the data. Yes or no? Tell me. ये भी मिल जाएगा. एक लिक्विड के लिए क्या वेपर प्रेशर है, एक और दूसरे लिक्विड के लिए क्या वेपर प्रेशर है. अच्छा, लेट अस से दैट वो भी नहीं मिल रहा अगर आपको, है ना. इफ यू डोंट अग्री, नहीं सर कैसे मिलेगा, पता नहीं मिले नहीं मिले, देन व्हाट वी विल डू, वी ऑलरेडी हैड वाटर ना, हमने ही बनाया है, राइट. सो वी ऑलरेडी हैड वाटर, सो वी कैन टेक वाटर, प्योर वाटर, and in another case we can take pure liquid B. Time बता देते हैं इसको, है ना. So here we can write, okay, this is, so we can put up a manometer here, and we can measure the P naught A, pure water है, and P naught B from here. Yes or no? All of you agree that all of these values can also be detected. Yes or no?
Yes, sir.
Okay. Now, if this measured thing that is experimental, and we will say that this is calculated, and because we are taking this P naught A and P naught B from data booklets, this is calculated. If there is any difference, between the experimental value and the calculated value, then it is non-ideal. And if there is if the experimental value and the calculated value, it is equal, then it is going to be ideal. Okay, it is going to be ideal. Now, why something can be non-ideal and why something can be non-ideal? ऐसा तो लगता है ना, it should be always ideal only. Why it is going to differ? Why it is going to differ? How can something become non-ideal? That means how can the experimental value be not equal to calculated value? I'm not saying that there will be calculation mistake. It's not like that. The calculation, all the calculation will be right, but still it will not be equal to experimental value. How it can happen? Let me tell you. Let us suppose we have, this is the intermolecular force of attraction between A particles. That is our solute, solvent. Solvent, we say that solvent is A, and the intermolecular forces of attraction is A. And there is BB. This is the intermolecular force of attraction in solute. Okay, A is the intermolecular force of attraction in solvent. BB is the intermolecular force of attraction in solute. Now, when we will mix this, तब क्या होगा? Then you will have AB type of intermolecular attraction between the solvent particles and the solute particles. Yes or no? Please tell me. है ना? यही तो होता है. If you have Na plus then what happens? Oxygen, it surrounds the Na plus, and you have the interaction between solvent and solute. Solvent and solute. Yes or no? Is it clear?
Yes, sir.
Is that clear, guys? Okay. Ab dekhiye. Please listen very carefully. Now we will just focus on the intermolecular forces of attraction. Intermolecular forces of attraction. We will compare it between the solvent, solute, and the solution. This is for solution. This is for solution. This is for solution. Achha. Let us suppose AA is equal to BB. ठीक है? For the simplicity sake, we can say that AA is equal to BB. इन दोनों का क्या है आपका बराबर. But what we saw that the intermolecular force of attraction between A and B, that means solute and solvent, is more. ठीक है? The intermolecular force of attraction between solute and solvent is more than individual solvent and individual solute. Then उससे होगा ये, what is going to happen? अच्छा, now you tell me. Here we are having A, and in the other container we are having BB, and here we are having AB. Now, since the intermolecular force of attraction is higher, will the AB particles evaporate easily? Yes or no? Tell me. Will they evaporate easily? If the intermolecular force of attraction is higher, then they are attracted to each other. No? AB particles, these are attracted to each other. That means, will they evaporate easily or with some difficulty? Tell me, guys. If the intermolecular force of attraction is higher, then will they be sticking together? Yeah, they will be escaping out. They will be sticking together or escaping out if the intermolecular force of attraction is higher. Hania, what do you think?
Sticking together.
Sticking together. Hishma, what do you think?
Sticking together.
Khalil, Mazia, Minashi, Nawal, Zarsh, what do you guys think? They will be sticking together, right? If the intermolecular force of attraction is higher, है ना? अच्छा, when they are sticking together, that means the total pressure, है ना? That means there will be less number of vapors. If there is less number of, if they are sticking together, that means they are not making vapors. If they are not making vapors, there will be less number of vapors. If there is less number of vapors, the P total will be less, right? The P total will be less, and that is why when you will measure the P total, it is going to be less than the P calculated. है ना? You understand this point? Yes or no? Please tell me. Because if you see the formula, here, that P total is equal to P naught A chi A plus P naught B chi B, right? Now in this, we are not considering what is the intermolecular force of attraction after the dissolution. After we have solvated the things, what is the force of attraction? We are not considering that. We are seeing individually. We are seeing this individually, right? But if there is some kind of attraction between the solute and solvent, which is exceptionally higher, then it is going to create problems, and the measured P total, it will be not equal to the calculated one. Is this clear how this P total can be different? First of all, tell me that.
Yes, sir. Clear.
Yes, clear ना? Okay, fine. चलिए. Now, this is the whole picture. अब इसमें देखिए एक और चीज आ जाएगी जो कि what we say in terms of energy and in terms of volume. Okay, so if we have AA type of interaction plus we have BB type of interaction in the reactant part, and in the solution we have AB and AB. Okay, AB plus, and here also AB is there, and we are seeing that here we are having attractive forces more. Okay, so if the intermolecular force of attraction is higher, if the intermolecular force of attraction is higher here, let us say this is V1, let us say this is V2. If the intermolecular force of attraction is higher here, then the volume of solution, it will be what? It will be less than V1 plus V2. Yes or no? Because if the intermolecular force of attraction is higher, that means they will be sticking together. If they are sticking together, they will be taking less volume than the individual volumes. Yes or no? Yes or no? You understand this point?
Yes, sir.
All of you. What about others? Huh? About the volume point? All of you, did you understand this?
Yes, sir.
Yes.
No doubt, no? Okay, now similarly, if I say that intermolecular forces of attraction is higher, that means these are making the intermolecular forces of attraction is higher, and whenever there is attractive forces, energy releases. Energy releases whenever you have attractive force of whenever you have force of attraction which is attractive in nature, and whenever there is a force which is repellent, if you are having, if there is rippling force of, अच्छा ये तो आप लोग को पता होना चाहिए ना, because if I have, let us say, positive and negative, है ना, that means the force of attraction is not equal to, it is equal to some constant k, q1 and q2. अब q1 आपका positive है and q2 is negative, that means the force of attraction is going to be, or it is going to be negative only, है ना, and when it is negative, that means it is attractive force of attraction. Yes or no? There is attractive force, and if you have, when the force is what, positive, पॉजिटिव होगा जब दोनों क्या हो जाए, पॉजिटिव हो जाए या फिर दोनों नेगेटिव हो जाए. So if something is positive, that means the force of, sorry, not the force of attraction, I should say the force. If the force is positive, then it is going to be repelling, and if it is negative, then it is going to be what, attractive. Yes or no? So whenever you have attractive force, whenever you have force which is attractive, energy releases. Energy releases means delta H is equal to negative. Okay, so we'll write these points later on. So what we have written till here, we have written that an ideal solution is defined as the solution which obeys Rawls law exactly over entire range of temperature, and you understand how the Rawls law can be disobeyed and how the Rawls law can be disobeyed. Now we'll write points like, please write here. Characteristics of ideal solution. Characteristic of ideal solution. So in ideal solution, what should be there? Number 1 point, the volume change on mixing should be 0. Volume change on mixing should be 0. Okay, that means if I mix two things, okay, if I mix two things, then it is, suppose if V1 and V2 are the volumes of the two component, then the volume of solution should be the sum of V1 and V2. Okay, so volume of solution should be equal to V1 plus V2, and this will be only possible. Now this will be only possible when the intermolecular force of attraction is, when the intermolecular force of attraction, wait a second, is same in the components, and in solution, All of you write this point. Let me know if you have any doubt here. The volume change on mixing should be 0. And what is the reason? The reason is that if the intermolecular force of attraction is same, then only the volume of solution will be equal to the sum of the volume of each component. Please write this down. Done, guys?
Done, sir.
Right, next point. Heat change. Heat change on mixing. Should be 0. No. So let us understand this point. Okay, don't write after this. Let us understand this point. You had AA, no, plus you had BB type of attraction, and it is giving you AB and AB type of attraction. Okay, that means you are breaking this two things, right? You're breaking these two bonds and you are forming these two bonds. Now, if the force of attraction is equal in all these three cases, if the force of attraction is equal in all these cases, then what is going to happen? The amount of energy that is required in breaking will be equal to the amount of energy that is required in forming. And that is why if these two, if the enthalpy, I would say, if the, let us say the delta H of breaking is equal to delta H of forming, that means I can say the delta H, sorry, yes, I like that. So enthalpy of breaking and enthalpy of forming is equal, then the delta H will be equal to what? 0. And that means there is no heat exchange. नहीं, जितना आपने एनर्जी लगाया है ब्रेक करने में उतना आपको फॉर्म करने में मिल गया, right? So at that time the heat exchange on mixing, it will be 0. Okay, heat exchange will be 0. Now in heat exchange what you can write here is, let me just reduce the size here. You can just see it here. Okay, heat exchange is what? Heat exchange, it should be 0. I will write here is when there is no change in the magnitude of attraction on the mixing of two components, on the mixing of two components, when there is no change in the magnitude of attraction on the mixing of two components, the delta H enthalpy of mixing will be 0. Okay, it should be 0. Then only it is going to be, ideal solution. Please write this down. Let me know when you're done. Heat exchange. Okay. So if you want to sum it up, then you can say that ideal solution, it should have, if you get a small note, then you can write ideal solution में क्या-क्या properties होनी चाहिए. One thing that you should never forget is it should follow, should obey Rod's law. Okay, should obey Rod's law. And this is why this is important, because Rod's law has an experimental basis, है ना, उसी से आप detect कर सकते हैं. And why should follow? And ideal solution के अगर हम theoretical level में जाएं, then I will say that the force of attraction or the attraction should be same on mixing. Okay, I've shortened it. Attraction of the components should be same on mixing. ये लिखना चाहिए, but it is attraction should be same on mixing. Then you can write what else? The volume change. Volume change should be 0. You can also write the delta H of mixing, enthalpy of mixing should also be 0. Okay. So if you don't understand any of this one point, please let me know, and I will explain it again. And when you are done, please raise your hand. If you're done, please raise your hand.
Sir, could you show the second point starting again?
So लिखना नहीं है, by the way. This one, na, breaking and forming. You don't have to write that point. I'll just explain it. Raise your hand when you're done. Okay.
Sir, ideal solution characteristics, second point,
Attraction should be same on mixing.
attraction. Okay.
Attraction between the components. Okay, attraction between the components should be same on the mixing. Okay, waiting for Hania, Khalil, Matthew, Salman, Sayyid Muhammad. Sayyid Muhammad, is your mic not working? Okay, Salman. Sayyid Muhammad. Okay, fine. So all of you are done. So you can write some examples here, okay? Examples for ideal solutions. Examples. So in examples, you can see if you have benzene and toluene. Okay, so obviously you can see that both of these are not even structurally very different, right? They are not very different structurally. We have just one carbon more in toluene, right? And normal hexane and just its successor, normal heptane. So heptane and hexane, both of these, they will form ideal solution. You will not see much change here. Okay, you will not see much change. Similarly, you can have chloroethane and bromoethane. So if you mix these two also, then also you'll be getting an ideal solution. The next topic is non-ideal solution. Second is non-ideal solution. So non-ideal solution, we can start by writing the solution which do not obey Raoult's law over entire range of concentration. These solutions, the solution which do not obey Raoult's law, which do not obey Raoult's law over the entire range of concentration. Over the entire range of concentration. Acha Zarsh, did you take any coaching for AMU's entrance examination?
Yes, sir, from turtle tutorials.
Which tutorials?
Some turtle tutorial. It's in Aligarh.
Acha, it is an Aligarh one. Okay. Turtle. Nice name though. Did they tell you about the original story of that name, Turtle Tutorials?
No, sir.
नहीं बताया.
No.
No, this is my just imagination. I think this is from that story, of rabbit and turtle, or hare or turtle. You know that story, all of you? Yes or no?
Yes, sir.
Yes, no. I think they must have that in their mind while naming it. Non-ideal solution. Okay. Solution which do not obey Raoult's law over the entire range of concentration. It means that the partial pressure of A which we are expecting, will not be equal to the product of pure vapor pressure of A into the mole fraction of A, and the the PB that we are expecting, the partial pressure of B, it will be not in the solution of in the solution, not equal to P naught B into chi B. And that is why the P total will not be equal to P naught A chi A plus P naught B chi B. And this is why we are getting a non-ideal solution. What will be the reason here? What will be the reason here? The reason will be, what will be the reason? Main reason will be what? The intermolecular force of attraction, the IMF attraction in solution will not be as that of individual components. Okay, as that of individual components. Now, if the attraction is not equal, that means the attraction can be either higher or lower. Okay, either higher or lower. Now, what will be the consequence if the attraction is higher? If the attraction is higher, then what is going to happen? The volume is going to be low, because if attraction is more, then the atoms and the molecules, they will be close together. If they're close together, they will be occupying less volume. So we will say what? We will say that the change in volume after mixing will be non-zero, है ना? आइडियल के केस में 0 होना चाहिए, अभी क्या होगा? non-zero. Second is about the enthalpy of solution and the heat change. So again, we have, please see here, AA plus BB, and it is giving you AB and AB. And AB and AB. Now here, if I say that here we are breaking the things, if I say, let us say that in the solution we are forming things, and I say the attraction is lower here, the attraction is lower. If the attraction is lower, then the amount that is required for breaking will be higher than the amount of energy that is released in forming. If you are giving in more energy and the energy release is not as that same, it is lower, then what is it? The enthalpy will not be equal to 0, right? The enthalpy will not be equal to 0. So I will just grab this. I hope you understood this point. Yes or no? Please tell me. The heat change. Yes or no, guys?
Yes, sir.
Okay. After mixing will be non-zero. It will be non-zero. Okay. So obviously from here also you can यहीं पे आपको समझ में आना चाहिए कि there will be two types of non-ideal solution. एक में ऐसा होगा कि इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन ज्यादा है, और एक में ऐसा होगा जिसमें इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन कम है ना? So where you are having higher intermolecular forces of attraction, and there is one case in which you will be having lower intermolecular forces of attraction. Okay. Done, guys? Please let me know when you're done. Okay. Then we'll write types of non-ideal solution. Types of non-ideal solution. Okay. Waiting for Khalid. Khalil, how are you?
Yes, sir.
How are you? Hello, Khalil.
Yes, sir.
How are you? I'm asking. आवाज ही नहीं आ रही
Some
आपकी आज तो क्लास में. Good. Okay.
Yes, sir.
I did not hear you, by the way. इसलिए हम पूछ रहे थे. Okay. चलिए. So most of you are done. Write the topic. Types of नॉन आइडियल solution, types of non-ideal solution. अब देखिए इसमें ना प्लीज अभी लिखिएगा मत, ठीक है, अभी प्लीज मत लिखिएगा। टाइप्स ऑफ नॉन आइडियल सॉल्यूशन, there can be two cases. If I'm talking about the experimental setup, तो हम लोग क्या मेजर करने वाले हैं, we can measure the p total. फिर डेटा बुकलेट से हम लोग क्या निकाल सकते हैं, we can calculate the p नॉट a chi a प्लस p नॉट b chi b। प्लीज लिखिएगा मत, ठीक है, प्लीज मत लिखिएगा p नॉट b chi b। एक तो केस ये हो सकता है, you are getting the p total that is greater than the calculated one, and there can be another case in which you are getting the p total, that means the measured one, it is what, it is lower than the calculated one, ठीक है, this is lower। अब इसमें देखिए how they have named these things, so if you have anything, if you have any solution which is showing the experimental value is greater than the calculated one, then we say that it shows positive deviation from Rod's law. Okay, and what will be this named as? This will be named as negative deviation from Rod's law। ठीक है, आसान है। If you have the experimental greater than calculated, अच्छा, let me ask one more time because these things are not generally used in your classrooms and all. All of you understand now when I say experimental and calculated? समझ में आता है ना आप लोगों को? Yes or no? Please tell me. Samaira, Nawal, yes, Khalid, yes, Hishma, tell me. When I say experimental and when I say calculated, Hishma,
Yes, sir.
अच्छा ये बात बताइए, experimental calculated में what is this value? It is experimental or is it calculated? P total.
Calculate.
Hania, what do you think? P total is experimental या calculated?
Experimental.
Okay. Khalid, what do you think? Acha, now raise your hand if you think this is experimental. If this is experimental, raise your hand. Okay, so Hishma, Mazia, Syed Mohammed, and Zarsh. Acha. So Mazia, आपको like you think it is calculated या फिर पता नहीं, confusion है? Mazia. Yes, Mazia, tell me. What do you think? This is calculated? Yes, Mazia.
Yes.
Okay, okay. Zarf, tell me, do you think this is calculated? Yes, Zarsh, tell me.
Calculated.
Calculated, okay. See. जब सिचुएशन कुछ इस तरह का होगा that you are having A component and B component, right? है ना? Then only you will be applying this particular formula which is an application of Rod's law. अब यहाँ पे आप बताइए जो P total है इसको measure करेंगे या calculate करेंगे? It can be measured ना? मैनोमीटर या बैरोमीटर लगा के, yes or no? Tell me. Right? All of you agree now? Hishma, Mazia.
Yes, sir.
Yes ना? ठीक है? So देखिए हम I understand that this whatever I'm telling you now it is a bit new. आपको लगता है सर ये क्या बात कर रहे हैं आप? P total तो कैलकुलेट करने का ही फॉर्मूला है ना? P total हम तो कैलकुलेट करते हैं, P नॉट A chi A को मल्टीप्लाई करते हैं, फिर P नॉट B और chi B को ऐड करते हैं, तब जाके तो हमको P total मिलता है। ये तो क्या है? ये तो कैलकुलेटेड है नहीं, where you are putting the information, where you are putting the values, that means you are calculating on this side. Okay, you are calculating on this side. Okay, so this is the calculating part, and इसको हम क्या कर सकते हैं, इसको हम measure कर सकते हैं. Okay, इसको हम measure कर सकते हैं. Now, no, not every time ऐसा नहीं होगा हमेशा कि you will have RHS जिसको calculate किया जाता है और LHS वो चीज है जिसको experiment में measure किया जाता है. It is not like that always. You always have to think and tell, है ना? You always have to think and tell कि कहाँ पे किसको measure किया जा सकता है, कहाँ पे किसको calculate किया जा सकता है. Okay, so I'm just deleting this part here. ठीक है? I hope you have understood this part, that positive deviation from Rolle's law. In that case, what is going to be, what is happening? The experimental value of the pressure is going to be higher, है ना? The experimental. So what do you think here? यहाँ पे अब ये बताइए. P total is higher. P total is higher. That means don't write here. यहाँ से आपको लिखना नहीं है, बस बताइएगा हमको. ठीक है? Vapor pressure is more or less? बताइए. All of you tell me. Please keep your turn your mic on. ज़्यादा टाइम है नहीं. Vapor pressure ज़्यादा है या कम है? What is the vapor pressure here? More or less? Tell me. Yes, Hishma, Hania, Khalid, Khalil, Mazia, Minashi, Samaira. Tell me, guys. Vapor pressure will be more or less? अरे जनाब, यहाँ पे जो वेपर प्रेशर होगा, इस वाले आप सिचुएशन देख के बताइए क्या होगा. It will be more or less? हाँ खलील, टेल मी.
More.
मतलब दिखने वाला है ना ये चीज तो, राइट? यू कैन सी दिस, राइट? सोचना तो नहीं पड़ रहा है ना. Yes or no? Samaira, Nawal, Minashi, Mazia.
Yes.
You all can see this ना, that vapor pressure is more. Vapor pressure is more. अब ये बताइए next statement. ठीक है, बिल्कुल समझा. Next statement. All of you can see, all of you can say that vapor pressure is more. Now you will tell me gas is escaping easily. Yes or no? Is the gas escaping easily? अगर वेपर प्रेशर ज्यादा, इसका मतलब क्या है? गैस आराम से निकल रहा है या दिक्कत से निकल रहा है? टेल मी. इजीली, yes or no?
Yes.
Yes.
All of you agree? दिख रहा है सबको? Gas is escaping easily. Gas is escaping easily, है ना? Please keep this chain of thought here only. Gas is escaping easily. Gas is escaping easily. That means particles of solution are sticking together. Yes or no? गैस आसानी से निकल रहा है, इसका क्या मतलब है? Particles of solution, they are sticking together. Yes or no?
No.
No.
No. ठीक है. If the particles are not sticking together, now tell me what should I ask next? अब ये बताइए, है ना? ये सवाल भी आपसे सवाल है कि हम नेक्स्ट सवाल क्या करेंगे?
Sir, IMF is
very good, है ना? What will be our next question? Our next question will be IMF. Intermolecular सैयद मोहम्मद का माइक ऑन हुआ है, बिल्कुल ही एग्जैक्ट टाइम है. Intermolecular force of attraction is high or low? Tell me.
Low.
Low.
Low. All of you agree? Yes or no? Tell me. ठीक है, कुछ लोगों का जवाब नहीं आया, बिल्कुल मुझसे एक बार कंफर्म कर लेते हैं. जर्श, you got all these 4 points
Yes, sir.
successively? Okay. Nawal,
Yes, sir.
Mazia, Minashi,
Yes, sir.
yes ना? एकदम पक्का तो? Yes or no? Tell me. See, types of non-ideal solution, ये आपको याद रखना पड़ेगा. If you remember ideal solution, in ideal solution what can happen? What can happen? IMF can be more and IF can be low, है ना? So you can have pressure in the Rolle's law. What can happen in the Rolle's law? In the terms of Rolle's law, there will be sometimes in some of the non-ideal solutions, the pressure that is experimental, it will be higher than the calculated, and in other case it will be lower than calculated. If it is higher than calculated, that means the vapor pressure is more. That means the gas is escaping easily. Particles of the solution are not sticking together, and the IMF is low. And the IMF is low. अब यहाँ पे ना people they have this contradiction. ये क्या होता है? सर यहाँ तो बोल रहे हैं कि पॉजिटिव डेविएशन है और यहाँ पे बोल रहे हैं IMF ऑफ अट्रैक्शन इज लो। ठीक है, सो इसको आप मत रखिएगा। पॉजिटिव डेविएशन का रिलेशन आप हमेशा रखिएगा किसके साथ? प्रेशर के साथ, है ना। पॉजिटिव डेविएशन फ्रॉम व्हाट? रॉल्स लॉ ना। एंड इन रॉल्स लॉ डू वी से एनीथिंग अबाउट इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन, या फिर हम प्रेशर की बात करते हैं? बताइए, इन रॉल्स लॉ व्हाट डू वी टॉक अबाउट? व्हाट डू वी टॉक अबाउट इन रॉल्स लॉ?
Pressure.
Pressure. So हमेशा whatever if you are remembering it, then remember it from this point of view that positive deviation from Rolle's law, pressure is more. Positive deviation from Rolle's law, pressure is more. Positive negative deviation from Rolle's law, pressure is less. Okay, and after that you can derive and you can come up to this point that intermolecular force of attraction is high या low. दोनों की केस में just opposite होगा. If it is positive deviation, then it will be low. If it is negative deviation, then it will be high. ठीक है, please this chain of thought you should remember. And we will explain this in detail. We will write about these things. We will write also some examples, right? Write also some examples. और ये भी बताया जाएगा like how come that component A, right, component B, these are having some intermolecular force of attraction. लेकिन जब A B आते हैं तो इनके बीच में repulsion होने लगता है, ऐसा कब होता है? And what is the case when you add AB, then there is more attraction here, है ना? कब हमारे पास ज्यादा attraction होगा तब negative deviation, कम attraction होगा तो positive deviation. Okay. So is this clear? Yes or no? Please tell me, all of you. Is this clear, guys?
Yes, sir.
Yes, sir.
Okay, fine. So there will be again a test on Sunday. Hopefully Sunday बहुत सारे लोगों ने Monday में दिया. I hope वो situation ना आए. There will be a test on Sunday. The topics. So the topics that we will be having, देखिए हम बोले चाहे नहीं बोले, solution chapter है, उसमें सवाल जो है concentration terms से आएगा ही आएगा. ठीक है, even if you don't get this as topic, शायद आप लोग को मैसेज किया जाता है. So even if the topic is not measured, even if the concentration term is not mentioned in the topic, but please remember concentration सवाल से तो सवाल आएगा ही आएगा. ठीक है, after that I will be giving you questions on solubility, right? If you don't remember solubility,
Again, you will take the test of concentration term.
नहीं, हम बोल रहे हैं एक टेस्ट होगा, उसमें concentration terms के सवाल होंगे, पूरा टेस्ट उसके ऊपर नहीं होगा. ठीक है,
Okay.
ठीक है. सॉल्युबिलिटी, अच्छा ये इस वजह से क्योंकि अब हर टॉपिक में जाते जाइए, आगे जाते जाइए, एंड तक आपके पास मोल फ्रैक्शन, मोलालिटी, सारी चीजें चलती रहेंगी, तो कंसंट्रेशन टर्म्स के साथ आपका राब्ता कांटेक्ट बना रहना चाहिए. ओके, वी विल बी टॉकिंग अबाउट सॉल्युबिलिटी, सबका, दोनों का, सॉलिड इन लिक्विड, ठीक है, एंड गैस इन लिक्विड. ओके, इन दोनों का इससे आपको आएगा. देन गैस इन लिक्विड में आपको याद होगा, so we had a detailed topic which is known as Henry's law. Henry's law से आएगा. I will also ask you from vapor pressure. Okay, I will also ask you from vapor pressure. हाँ चलिए ठीक है, इतना ही रखने रहते हैं आज. Solubility, Henry's law, vapor pressure. Rolle's law में अभी हम लोगों ने मतलब सवाल तो कर लिए हैं कुछ, ठीक है, लेकिन रॉल्स लॉ को हम उस तरफ रखना चाहते हैं जहां पे आपके पास रॉल्स लॉ, आइडियल सॉल्यूशन, नॉन आइडियल सॉल्यूशन, इन सबका साथ में दे देते हैं ना, तो आपको एक टॉपिक ही खत्म हो जाएगा. ठीक है, तो यहाँ तक आपके पास आएगा संडे के दिन. टेस्ट विल बी ऑन संडे. ऑल्सो वन मोर अनाउंसमेंट इज दैट ऑन फ्राइडे 4 PM KSA टाइमिंग यू विल हैव अ क्लास ऑन कंसंट्रेशन टर्म, बिकॉज कुछ बच्चे जिनका छूटा हुआ है कंसंट्रेशन टर्म. ठीक है, so we will do concentration term on 4 PM.
Friday as in tomorrow, right?
Yeah, as in tomorrow.
Yeah.
ठीक है, 4 PM से लेके it will go till 6:30 I would say, जो आपका नॉर्मल क्लास का टाइमिंग है आज की तरह. अब ये बताइए who all will come to this class, तो फिर मीटिंग लिंक आपको भेज दिया जाएगा. प्लीज रेज योर हैंड. कंसंट्रेशन टर्म में जो जो आएगा. ठीक है, 3 स्टूडेंट, हाँ इनका नाम तो हमको याद था, नवाल, जर्श एंड मैथ्यू. ठीक है, सलमान आप भी आइएगा. हाँ सेम थिंग, एग्जैक्टली सेम थिंग, कुछ नया.
So there's no new problems.
पता नहीं, दैट आई कांट से. ठीक है, नॉट आई वोंट से दैट देयर विल बी एनी न्यू टाइप ऑफ प्रॉब्लम, कुछ मतलब सेम ही सवाल रहेंगे ना. ओके, कुछ नया टाइप तो हम नहीं देंगे उसमें. but there can be new problems. Okay. सलमान आपको भी करना है क्या क्लास? आप थम्स अप करके रखे थे।
No, that was for like the test.
अच्छा वो, अच्छा टेस्ट की था। अच्छा so concentration term नवाल, जर्श और मैथ्यू, नो वन एल्स ना। हाँ बाकियों का तो हो गया कंसंट्रेशन टर्म। चलिए ठीक है, थैंक यू वेरी मच। ओके सो जर्श, नवाल, ऑल ऑफ यू आर अंडरस्टैंडिंग यस और नो, इवन दो यू हैव नॉट डन कंसंट्रेशन टर्म? समझ में आ रहा है अब तक सब कुछ?
Yes, sir.
Yes, sir.
ठीक है, ओके सर, फाइन गाइस, थैंक यू वेरी मच। वी विल मीट अगेन टुमारो 4 PM। चलो बाय, थैंक यू, अस्सलाम वालेकुम, टेक केयर।
Thank you, sir.
Sir, Allah Hafiz.
अल्लाह हाफिज़, अस्सलाम वालेकुम।
Thank you, sir.
थैंक यू,
Sir.
थैंक यू। यस यस, टेल मी हिश्मा।
Sir, do you have like recorded lectures of electrochemistry numerical?
इलेक्ट्रोकेमिस्ट्री न्यूमेरिकल, आई डोंट नो एक्चुअली। आपको इलेक्ट्रोकेमिस्ट्री में कुछ प्रॉब्लम्स हो रहे हैं?
Yes, sir. Like I have exam from that chapter. So
एग्जाम कब है एग्जाम आपका?
on Monday.
अच्छा मंडे को है। तो एक बात बताइए, इलेक्ट्रोकेमिस्ट्री में आपको कौन से टॉपिक में दिक्कत हो रही है?
So just the numerical problem.
नहीं, देखिए इलेक्ट्रोकेमिस्ट्री में 3 पार्ट्स हैं। देयर इज वन थिंग व्हिच इज जिसमें गैल्वेनिक सेल आता है, राइट? डैनियल सेल, गैल्वेनिक सेल वाला जो पार्ट है। देन यू हैव इलेक्ट्रोलाइसिस, राइट? एंड आफ्टर दैट देयर इज कंडक्टेंस।
Yes, sir. Electrolysis from then onwards it's okay, but the initial parts like from the beginning of the chapter.
अच्छा तो एक तो, अच्छा सबसे पहले ये बताइए, आपको स्टैंडर्ड ऑक्सीडेशन पोटेंशियल, रिडक्शन पोटेंशियल, उसमें दिक्कत आ रही है कि ई नॉट सेल कैसे निकालना रहता है?
Sir, the formula is fine, but then sometimes the writing that the cell, the sons and all this.
सेल लिखने का तरीका क्या होना चाहिए, उन सब में दिक्कत है?
Yes, sir.
अच्छा, आई विल टेल यू अ फ्यू थिंग्स हियर, ठीक है? उनको अप्लाई करके देखिएगा, नहीं हुआ तो यू कैन ऑलवेज मैसेज ऑन लर्निवियो, ठीक है ना? अब वो लाइक इफ यू वांट, लेट मी थिंक, डाउट्स हैं आपके पास पर्टिकुलर, ये सवाल में डाउट है हमको, ये सवाल में डाउट है, ऐसे डाउट्स हैं?
Not
नहीं, अभी तक हिम्मत नहीं हुई सवाल उठाने की, ठीक है, हम समझ, अभी तक हिम्मत नहीं है सवाल उठाने की। सी, मेकिंग ऑफ सेल, दे आर आस्किंग यू टू रिप्रेजेंट द सेल, उसमें दिक्कत है हिश्मा?
yes, sir.
ओके, सी, ये याद रख लीजिएगा, ABC, ठीक है?
Okay, sir.
ABC, ए से क्या हो जाएगा? एनोड, बी से हो जाएगा ब्रिज, एंड सी से हो जाएगा कैथोड, ठीक है? नाउ 2 रूल्स, नाउ दिस इज विदाउट एनी एक्सेप्शन, ठीक है? हमेशा याद रखना आपको, एनोड में पॉजिटिव नेगेटिव, कैथोड में पॉजिटिव नेगेटिव कभी मत याद रखिएगा, ठीक है? व्हाट इज पॉजिटिव, व्हाट इज नेगेटिव, वो आपको याद ही नहीं रखना है। एनोड में क्या होता है? ऑक्सीडेशन, ऑलवेज रिमेंबर दिस पॉइंट। एंड कैथोड में हमेशा क्या होगा? रिडक्शन, ठीक है? इज दैट राइट हिश्मा?
Yes.
ठीक है। ऑक्सीडेशन किसका होगा? आपको बोला जाएगा कि हाँ, आपने, उन्होंने क्या किया, 3-4 आपको इलेक्ट्रोड पोटेंशियल दे दिए, राइट? ई नॉट दे दिया, बहुत सारी चीजों का, लेट अस से 1 का दे दिया, 2 का दे दिया, 3 का दे दिया, और उसके बाद बोला कि कंस्ट्रक्ट सेल्स फॉर दिस, कंस्ट्रक्ट अ सेल, या फिर 2 का ही दे दिया, उसने बोला कंस्ट्रक्ट अ सेल। आपको ये समझ में नहीं आ रहा कि एनोड में किसको रखना है, कैथोड में किसको रखना है? देखिए, एनोड में ऑक्सीडेशन होता है, और ऑक्सीडेशन किसका होगा? जिसका आसानी से हो जाए, ठीक है? रिडक्शन किसका होगा? दीज आर वेक स्टेटमेंट, आई अंडरस्टैंड, लेकिन आपको समझ में आ जाएगा, ठीक है? जिसका आसानी से हो जाए, ठीक है? अब लेट मी पुल अप वन क्वेश्चन, ठीक है, जिसमें वैल्यूज होते हैं, हम थोड़ा सा आपको बता देते हैं तो शायद आपको आइडिया लग जाए। कंस्ट्रक्ट अ सेल फ्रॉम द